But coming up next, we have another great speaker. And I'm really excited for this session. It's going to be so much fun. Highly scalable games with Azure Serverless with LaBrina Loving. It's going to be awesome. So let's watch. Hi, LaBrina. Are you ready for this?
I am ready. Let me just share my screen. You guys see my screen?
We don't see it yet. Oh, now we do.
Oh, yay! Woo! We're so excited.
So yes, I am so glad to be here. I've done a couple of conferences here before, but this is my first time talking about gaming. So I'm excited to be here. I'm excited to talk about how serverless can help game development. So as everyone mentioned, my name is LaBrina Loving. I work in developer advocacy for our gaming ecosystem organization here at Microsoft. And today we're going to talk all about building highly scalable games with Azure Serverless. So over the years, games have gotten more data intensive, more compute intensive, and there are some amazing games out there that are really leveraging the power of cloud. But I wanted to have a discussion about how we can actually leverage the power of serverless. So today you might actually be hosting your game on-prem, or you might be hosting your game and the services that support the game. Maybe you might already be hosting it in the cloud, but you might be using something like virtual machines. So today we're going to talk about how you can leverage the benefits of serverless to host your game. So for today's games, there are a lot of online services that actually power games. Games require a lot. Things like leaderboards, matchmaking, authentication, player-to-player messaging, currency, tournaments, and analytics. And on top of that, if you're doing multiplayer game, you have to worry about hosting. And as always, you have to worry about the ever-growing scale of player data. So there is a lot to think about, a lot of services. And although you may already have created services for some of these, it's really great to leverage serverless as a way to actually take some of the burden off your development. So today, hosting options for your game come in a lot of different flavors. So, and the flavors, it's definitely a choose your own adventure. And the way you think about it, this is really about how much you want to manage and how much you want Azure to manage. And that can vary based on the requirements of your game and based on just where you are in your cloud journey. So we start all the way over at the left when we talk about infrastructure as a service. That's definitely where we at Azure are managing the infrastructure, hardware, and networking and the facilities, but you're still managing patching of servers, you're still managing application code, security, config, provisioning, the list goes on. Then let's talk about a little bit container platform as a service. So this is where you're actually having your game and its services are running inside of a container, and Azure is maintaining the container orchestration plane, still also the physical hardware, software, and facilities. And then you manage the application code, the data source integrations, and you're managing those container clusters. And for that, we have a service called Azure Kubernetes Service, or AKS. Then there's platform as a service. which is where we will continue to do all those same things, but you're managing the scale of the web application. And then there's functions as a service, which is what we're primarily going to talk about in the session, which is where at this point we as an Azure are managing everything except for your application code, except for your game development code. So you can focus on building your game, and we focus on everything else for you. And then the last thing in the corner, last service in the corner, which is really great, which is integration platform as a service. So this is, we have a service called PlayFab. And with this service, it actually comes, a lot of the services that we talked about, like leaderboards or matchmaking, can actually be services that you configure. And then you could possibly combine function as a service and integration platform as a service together to extend PlayFab as well. So you might be thinking, if you're already building your game, why should you use serverless? Why is serverless important for gaming? So with serverless, you actually can scale automatically. We handle the scaling for you. We manage high availability. We manage the servers for you, and you kind of focus on code. It's very cost effective because in this case, you pay only for the compute time that you use. So if you have a leaderboard that is running in an Azure function, you pay for the time that leaderboard service is called and doing work, and then you don't pay for and then you're done. And then so actually in this case, you're paying for just the compute time for processing those particular events, and that's it. And then because of this, you actually just can focus on your game, not on provisioning infrastructure, figuring how much infrastructure you need to buy, figuring how to scale it, how to replicate that infrastructure across the globe. We manage all of that for you in Azure. So let's take a look at kind of the inventory of serverless features and options that you can choose for powering your game. So we talked a little bit about Azure Functions. So Azure Functions allows you to run compute, and it allows you to run application game code in the cloud, and you can run various services. It can be event-based. It can be triggered off of things like messages that happen. It can be triggered based off of an HTTP endpoint. It can be time-based triggered. There are a lot of different event-driven ways, and it feeds really well into your event-driven architecture. API management is our front end for having security in front of your environment. So it handles things like SSL offloading. It can handle security, other things like that. Then Event Hub and queues can be used for managing your messages that could scale at scale. So as you're streaming events, telemetry events for player data, you can use Event Hub and queues to manage that. Stream Analytics is our stream processing service, and Azure Cosmos DB and Azure SQL are our database, Azure Cosmos DB for NoSQL, and Azure SQL for relational databases, and Blob Storage for unstructured data. And then to kind of monitor and support all of the events and all of this, we have Azure Monitor and Application Insights. So what I thought I would do is actually let's take a look at a reference architecture. for actually doing something in your game for matchmaking. So when typically when you're doing matchmaking, there is a lot of concerns that occur, figuring out how the logic to match users across the globe, figuring out the right latency, figuring out how to minimize latency, and then still handling things like what happens when the user might cancel or leave the game. So there's a lot of concerns that can happen while managing your game. And so we can leverage the power of the cloud and serverless to do all of these things. So let's take a look a little bit at the diagram that I have. So let's imagine that we have a game player that comes in through a device client. They will get added to a queue. They will use traffic manager and API management to route their requests to the closest region. So if you have users coming in from Europe or from Japan or from the US, they will get routed to the appropriate Azure region that's closest to them. Then that request gets placed on an event hub. Then we have a Azure function that actually will take that message and process it and figure out where this player creates a ticket for the player, a message, and tries to figure out the appropriate game session for that user. Then we have another function that will add the player to the server. Then we have this kind of a layer at the bottom where we're doing a match request. And that actually is an orchestration that happens. And so during that match request, we create another Azure function to determine where the player should be matched. And then we put, and then when we're done, we figured out the right matching, then we can put a message on the Event Hub and trigger that, and then the player is ready to start playing. So I'm going to show a little bit of the code behind the scenes for how to make this work. Second. So here I've got a set of Azure functions that I've created. So I've got an Azure function called our batch add player. And this is triggered, as you can see, it's triggered from my Event Hub. And then what that does is it starts kicking off an orchestration. And what that orchestration can do is start connecting and figuring out where the player should be matched to. So I've got some processing logic here that just takes the player information and deserializes it. And then I start creating a hash key that'll store in a Redis cache to maintain the session information for the player. And so this code actually is pretty easy to get started. And then once we have this code written and set up, then I can actually deploy that as an Azure function. That Azure function would be running in the cloud, and every time a new player gets added, requests a game server, requests a match, this code can run. And so it can run at scale, and basically after you write your matchmaking service, you actually deploy it and you're done. You don't have to worry about hosting. You don't have to worry about other infrastructure concerns and scaling. This is all done for you. So I've got just to kind of show, I've got a bunch of, I've got a quick little game that I'm gonna just play real quick and start firing off some events. And then what I'll show happening is that when I start my gameplay, we'll actually be able to see that in our server. So let me get that going. It's taking a little bit of time to get my game started. So anyway, so what I've done is I've provisioned what is called an event hub. An event hub is what we use to store all of our player data, telemetry, and messaging. And so, I can take a look at this event hub. I've created an event hub. First thing you do is you create an event hub namespace. And then what I've done is went ahead and created an event hub instance. And this event hub instance, I've called it player data. I've actually started capturing events. So you can see over time, like the number of requests I started pulling in. So I've got like over 3,000 requests that I just started pumping through from playing my game over, or simulating playing my game over time. And so you can see these events have been captured here. And that the code that I showed before, my game server, what it does is it actually connects to those Azure Functions, which then places the events on an event hub and then triggers the remaining code to actually do the matchmaking events. Let's take a look. So now that I have my player events and telemetry going to an event hub, and I've got a lot of player data and matchmaking happening, one of the things that I want to do is start doing some analytics. So the great thing, but because of the way that game data is growing, there's some challenges with doing gaming analytics. So data is very critical and to game success. And there's an ever-growing amount of telemetry over time. There's a lot of siloed data that's aggregated. So you might have player game data, you might have player profiles, you might have just the actual gameplay that's happening. So you'll have a lot of data that grows over time. And it drives a lot of important key decisions on how you grow your game, how you continue to evolve your game, how you monetize and keep players coming. And you really want to be able to have the game data to be provided in real time to power decisions. So, and then you want to be able to bring your existing tools to analyze the data. So what I want to show as a second is to really show how you can use the power of serverless to actually stream data in real time, be able to make decisions as well. So let's talk a little bit about the tools that we'll use for streaming data in real time. So the first thing we'll be streaming that Event Hub data that we started creating when a player from our player events. we'll use another service called Azure Stream Analytics to stream it. And then I'll show a little bit of how you can use different reporting tools of your choice to actually report and visualize that data. So let's go back to our Azure portal. And so what I've already done is I've provisioned a stream analytics job. And when you create a stream analytics job, there's a couple of things that you want to do. So the first thing that you have to do is you have to create your inputs. So I've created already an input data stream, but let's just see how I could create an additional one. So when I create an input data stream, I can actually create it from either an Event Hub, IoT Hub, or Blob Storage, but I'm going to create it from an Event Hub. And so this gives me the idea. Oh, my job is still running, so I can't actually show. But so this actually will walk you through creating an Event Hub. Let's take a look at the one that I already have created. So I just went through and created an Event Hub. I created it from my Event Hub namespace. Called player data. Here's my Event Hub, and then it just creates the connection string. And then it creates a policy. Policies are used to create fine-grained control to your Event Hub and to your data. Actually, I'm going to go ahead and stop my job so we can actually execute a few queries too. So the next thing that I'm going to do is I'm actually going to create an output first. And you can add outputs as well. There's a lot of different ones you can create. I created a Power BI output. Power BI output will actually allow me to connect and stream my data in real time and connect it to my job. So actually, at the end of the day, just with a few clicks, I can stream player data in and then actually connect it right to a Power BI report. So here's my Power BI outputs. I've created a data set called player data set and created a table here. We'll quickly see how that works. Just doing a quick time check here. And then as you can see here, there are various ways that you can output your data. You can output it back out to an Azure function. You could store it and keep it in Cosmos DB for other considerations. You can put it in a data lake so that you can combine it with other data to do other further analysis. But I've created mine out to a Power BI report. And then what I wanted to do is actually kind of show a little bit about this. So I'm capturing things like player country and the number of game counts and things like that. And so what I've done is I've created a query, and your query is what you actually do to capture the data as it's streaming in from Event Hub. And then what I've done is I've created a tumbling window to capture it every, this is a tumbling window every 5 seconds. So if I test my query, oops. Oh, I may not have it. I need to stream some data. But this actually would show our data for in real time. And then at the end, I could now go to my Power BI report and actually show my data in being captured in real time. So So let's see if I can get this kind of started again. And I'll just quickly show, because I know it looks like we're running a little bit low on time. So I'll just quickly kind of show the process of actually taking that and combining it with Power BI data. So if I go here. Just bring up my report. I'll see because I created because I already created and connected my player data. I've now got a data set here that I can see through my Power BI report. And then I also can create a Power BI dashboard to capture that player data. So really just within a few minutes of simply clicking, you can take player data, ingest it, query it, and then be able to output it to do like real-time streaming to your dashboard. Let's see. Since we're running a little low on time. So that's sort of our those are sort of two instances where you can actually take leverage serverless for for improving and building your game. So we talked about actually using serverless for actually running all of the APIs and functional code for your game development. And then we talked about using serverless for streaming your data in real time.
Thanks very much. That was great.
Yeah, thank you.
We had a quick question for you, if you have a minute. Sunita was curious why you chose Event Hub over storage queues or Service Bus.
Yeah, so the reason why I chose Event Hub over storage queues and Storage Bus. So the reason why you think about the difference between Event Hub and queues are really you have to think about what the purpose of what you're doing. So event hubs are best used for events. So saying like this happened, like this player is requesting a matchmaking event, or this player quit the game. So those are actual events where I want to take further action versus a queue where it's really about just sort of reading data. So that's actually why I chose an event hub versus a storage queue. But in some cases, it could work very well the same, but it also depends on the scale that you're looking for as well.
Yeah, that makes a lot of sense. We have a lot of good sessions coming up. What's coming up, Nydia?
Yeah, and LaBrina, we got to talk after. So I'm gonna go. That was awesome. So thank you so much.